Alright, this is the review for the Unit 6 test. My review is going to look a little different than those who printed it in my class. I added this statement side later, but regardless, you can fill it in as we go through. Alright, so let's start. We're trying to prove that W is congruent to Y and Z is congruent to X, knowing that this is a parallelogram. That's all we know, it's a parallelogram. From the definition of a parallelogram, we should all be used to this by now. Definition of a parallelogram: opposite sides are parallel. So number one should definitely be the easiest given. Do not get that wrong. Then WX is parallel to YZ, WZ is parallel to XY. I just did that from the definition. So this is definition of, and this is the symbol for parallelogram, just so I don't have to write out parallelogram. Okay, from there, I'm going to go ahead and say that ZYW, this angle, is congruent to XWY, that angle. If these two lines are parallel, then those two angles are alternate interior angles. WX is parallel to YZ. That shouldn't say parallel. This should say congruent. WX is congruent to YZ. WX, YZ. This is a property of parallelograms. This is another one. It should say congruent, not parallel. And this is WY is congruent to WY. Reflexive property. Anytime you have anything congruent to itself, reflexive property. The two triangles are then going to be congruent. I have side, angle, side in the top triangle, congruent to side, angle, side in the bottom triangle. So they're congruent, side, angle, side. Anytime you have triangle congruence, the very next step, CPCTC, corresponding parts of congruent triangles are congruent, and your proof is done. Alright, number two. What is the area of rectangle JGMN? JGMN. So it says area, which is just base times height. I have to find one side and then the other. Now, there's two ways to do this. I'm going to go ahead and just do trig. So I need this side. I have this angle and that leg. This is opposite my 60. This would be my hypotenuse. Opposite hypotenuse, that's going to be sine of 60 degrees is going to equal 12 over x. My variable's in the denominator, so I just switch them and it becomes x equals 12 divided by sine of 60 degrees. This is what I'm plugging into the calculator for this sine. Once I find that side, then I need to find the long side. In order to find the long side, this is a 60 degree angle. That's 90, which means this is a 30, 60, 90 triangle. So this is 30 degrees. They did call it a rectangle, so I know this angle is total 90 degrees. If this side is 30, that means this side has to be 60. And now I have trig all over again. I'm trying to find this side, the long side, which is going to be, if I use this 60 degree angle, This 12 is then adjacent, which gives me cosine. So cosine of 60 degrees is equal to adjacent over hypotenuse. Same thing, your variables in the denominator, so you switch them and it becomes y equals 12 divided by cosine 60 degrees. Now let's plug this in. Let's do the sine first. So 12 divided by 60 sine equals is 13 point, we'll do 86. So this side is approximately 13.86. The long side is going to be 12 divided by 60 cosine 24. So this is approximately 24. And now it says area, so it's 24 times 13.86. So the 24 times 13.86 is approximately, the area is approximately 332.64. Alright. Next, 3. ABCD is a parallelogram. The diagonals intersect at point W. List all the information known about ABCD at point W. Well, it's a parallelogram. Opposite sides are parallel, opposite sides are congruent, and the diagonals bisect each other. Therefore, all of these triangles that you see, the opposite ones are congruent. These two triangles are congruent, side, side, side. These two triangles are congruent, side, side, side. So we're going to say the triangles opposite each other are congruent by side, side, side. What can you conclude about the triangles created by the diagonals in a rhombus? Well, there's no picture this time, so let's draw a rhombus. Let's draw the diagonals. What do we know? Diagonals bisect each other. In a rhombus, all sides are equal. So the triangles created by the diagonals in a rhombus, all of them are congruent, side, side, side. You can even do HL. You can do any of it. Number 5, in a kite, knowing that the long diagonal bisects the two angles, how would you prove that the two triangles created by the diagonal are congruent? Let's draw a kite. No picture, draw a picture. The long diagonal bisects the angles. It says, how would you prove two triangles created by the diagonal are congruent? So we're trying to prove these two triangles are congruent. Well, this side is congruent to itself, reflexive property. So in the triangle on the left, you have angle, side, angle. On the triangle on the right, angle, side, angle. So the two triangles are congruent, angle, side, angle. 6. What additional piece of information is needed to prove that the quadrilateral ABCD is a rhombus, given that all of that stuff is true? This was actually a bell ringer. Here is my shape. A, B, C, D. AB is parallel to CD. BC is congruent to CD. There is not enough information. Supplementary doesn't help me in a rhombus because the squares, supplementary, these are consecutive angles, and that's a square, parallelogram, rhombus, rectangle, and isosceles trapezoid all have complementary, supplementary, or consecutive supplementary angles. AD being parallel to BC. AD, if this was parallel to that, that is the winner. AD is congruent to BC. If AD is congruent to BC, that means you have three congruent sides. You can draw a trapezoid with three congruent sides. The fourth one's not. So the sides must be parallel. A rhombus is a parallelogram. If you knew opposite sides were parallel, then it would help you prove that that is a rhombus. Alright. Number 7, given one piece of information about quadrilateral TCHS, which of the following options would be sufficient to determine that TCHS is a rhombus? Select all that apply. The coordinates, always. Coordinates will always be useful. Coordinates you can use distance formula, Pythagorean theorem, slope, all of it to prove if it's a rhombus or not. The length of each side, that would help, because in a rhombus all sides have to be equal. The measure of each interior angle. In a rhombus the angles, opposite angles are equal, but that doesn't necessarily tell you if it's a rhombus, or it might just be a parallelogram. TCHS has two pairs of opposite sides that are parallel. Again, that's just a parallelogram. Square, rectangle, rhombus doesn't guarantee that it's only a rhombus. TCHS is a square, yes, because a square is a rhombus. The diagonals of TCHS meet at 90 degrees. No, because it could be a kite. You never know. Alright. 8. Another proof. There's 3 proofs on this test. 8. We're trying to prove that it is a parallelogram, so we're trying to prove opposite sides are parallel. Right off the bat, I see this. I see a diagonal. I see that it's in both triangles. It's right here. BD is congruent to BD. Reflexive. You have AB parallel to CD. AB, let's draw this stuff in. Parallel to CD. AB is congruent to CD. Given. ABD is congruent to CDB. The parallel lines, that gives you alternate interior angles. We already said the reflexive property. Now I have side angle side in each triangle. As soon as you have this and you have another step, your next step is automatically CPCTC, which tells you that AD is congruent to BC. And now ABCD is a parallelogram. Properties of parallelogram. Parallelogram opposite sides are congruent. Alright. Number 9 we didn't go over. Number 9, there's 2 questions on the test like this. Whenever you see an angle, this is a quadrilateral. This is a 4-sided shape. 1, 2, 3, 4. 4-sided shape inside of a circle. The angle is, or opposite angles, quadrilateral inside of a circle. Opposite angles are supplementary. Opposite angles are supplementary. That's going to be huge. Opposite angles add to 180 degrees. So angle M plus angle T add to 180 degrees. Alright. Number 10. Here's the math for this. Find X and Y. Just told you opposite angles add to 180 degrees. So this is opposite. You have 43 plus 3x plus 45x minus 7 equals 180. 45 plus 3, this is 48 plus x plus 36 equals 180. Subtract 36 and you get 48x equals 144. Divide by 48x equals 3. For your y, it's 7y minus 6 plus 21y minus 10 equals 180. This becomes 7 and 21 is 28y. Negative 6, negative 10 is negative 16 equals 180. Add 16, 28y equals 196. 196 divided by 28, y equals 7. Are you done with just your x and y? Yes, because that's all they said. X and y. Alright, I'm going to do 11 through 15 and upload those in a separate video later.